How we doing, guys? So this is the start of our study of hydrostatics. We're looking at Fundamental Applied Maths, chapter 9.1, page 163. We're starting off with questions. We're going to do questions 1, 2, 7, and 11 there. Starting off here with question 1 and question 2, which I'll do quite quickly. The relative density of an oil is 0.83. What is the density of the oil in kilograms per meter cubed? Well, the relative density is the density compared to water, and the density of water is 1,000 kilograms per meter cubed. So you just multiply 0.83 by 1,000, and that gets you 830 kilograms per meter cubed of oil is the density, and that's the unit we're going to be using for density for the most part. Equivalent units you could use might be, other units might be grams per centimeter cubed, but we're typically going to use that one. Question 2 tells us the density of balsa wood, which is a light type of wood, is 375 kilograms per meter cubed. Find its relative density. Well, that's compared to water. It's 37% of the density of water. So dividing through by 1,000 kilograms per meter cubed gives us S, is what we use for relative density, is 0.375. And it's dimensionless because you always multiply by the dimensions of the density of water. Rho is the symbol we use for density, by the way. So yeah, if you haven't picked up, density is mass divided by volume, which is a junior cert formula. Hopefully you remember it from junior cert science. Question 7, iron of relative density 7 and nickel of relative density 9 are mixed in a 10:1 ratio of volume. Find the relative density of the alloy formed in this way, correct at 3 places of decimals. So if you have iron with a relative density 7, that means it has a density of 7,000 kilograms per meter cubed of iron, and nickel has 9,000 kilograms density per meter cubed. So density is mass divided by volume. So if you mix these with a 10:1 ratio iron to nickel, that's going to be 70,000 kilograms of iron for every 9,000 kilograms of nickel. It's going to give a total mass, if it was, say, a 10 meter cubed to 1 meter cubed ratio, that'll be a total mass of 79,000 kilograms. The volume then will be 10 parts iron, so let's say 10 meters cubed of iron plus 1 meter cubed of nickel. Okay, but it's 10:1 volume, and actually it doesn't matter what unit you worked in. If it was a 10:1 ratio, centimeters cubed or feet cubed or cubic inches, it wouldn't matter. You get the same answer here, which is 79,000 kilograms for every 11 meters cubed, which will be a density of 79,000 over 11, 7181.8 kilograms per meter cubed. Now we're asked for the relative density, so that's the density of the material. The relative density, we tend to use S for relative density, is that divided by 1,000. Compared to water, it would be 7.182 times the density of water. Question 11 says a bucket of height 18 centimeters, smaller radius 6 down the bottom and larger radius 9 is filled with water. Find the weight of water in terms of G and of pi. This shape here in 3 dimensions is called a frustum of a cone. It's like what you get if you chop the bottom off a cone, or the pointy bit off a cone. I'll move on to parts 2 and 3 in a second. So the first one, the volume of a frustum formula is on page 11 of your log tables, and it's there. So that's going to be 1/3 pi. The height of our thing is 18. The larger radius is 9 squared plus 9 times 6, larger by smaller, plus the smaller radius squared. And that is going to give you a volume in centimeters cubed. Okay, now because we like to work in meters cubed, we need to know, well, how do I convert from centimeters cubed to meters cubed? Because all of my measurements here were in centimeters. So, two ways to do this. One, you can either actually, at the start of the problem, work in centimeters. So call that 0.18, 0.09, 0.09, 0.06, 0.06. That'll get you the right answer. Or if you know that 1 meter cubed is a cube of side 1 meter, or 100 by 100 by 100, you can see that 1 meter cubed is the same as 100 centimeters cubed, okay, which is 1 million. So there are 1 million centimeters cubed in a meter cubed. So I can just take that answer and divide it by a million to get my answer in 10 to the 6 is the same as a million, to get my answer in meters cubed. So if I go to my calculator, 9 squared plus 6 times 9 plus 6 squared is 171 multiplied by 6 pi. That's 1026 multiplied by pi, and then I'm going to divide that by 10 to the 6. So divided by 10 to the power of, excuse me. Okay, which is going to give me 1.026 times 10 to the minus 3. 0.26 times 10 to the minus 3 meters cubed. And that should say pi. Sorry, because I got that in terms of pi. Okay, so the weight of water is, well, if that's its volume, multiplying by the density gives us the mass, okay, according to this formula over here. Mass density multiplied by volume. So that's mass times gravity will give us the weight of the water. So it's the volume, 1.026 pi times 10 to the minus 3 times the density of water is 1,000 kilograms. This is meters cubed. It's 1,000 kilograms per meter cubed times g. Okay, so that's just going to cancel out that 10 to the minus 3, and we're going to get 1.026 pi g. There's the weight of water, and that's going to be in newtons. Sorry about that now, it's a little bit cramped. Part 2 is almost the same type of question. A bucket with the same dimensions is filled to 1/3 of its height with alcohol, so the height is now only 6, so that the surface of the alcohol is a circle with radius 7. So you've got a 7 as the radius in this part, but it's still a frustum shape. The relative density of the alcohol is 0.95. Find the weight of the alcohol. So the volume again is 1/3 pi times 18 times, this time it's 7 squared plus 7 sixes plus 6 squared, and again divided by 10 to the minus, or 10 to the 6. So the volume here is going to come out as 7 squared plus 7 times 6 plus 6 squared is that, multiplied by 6 pi is 762 pi. 2 pi. Divided by 10 to the minus 6, so that's going to be 762. I'm going to leave it as 10 to the minus 6. Okay, just dividing by 10 to the 6 is the same as multiplying by 10 to the minus 6 meters cubed. Weight is volume, 762 pi times 10 to the minus 6 meters cubed, multiplied by density. Now, this has a relative density of 0.95, so its density is 950 kilograms per meter cubed. Okay, that's 0.95 multiplied by 1,000 multiplied by g. Okay, so if we carry that out, we're going to say that multiplied by 950 gives us 723,900. Remember, we're multiplying by 10 to the minus 6 as well. So we're getting 0.7239, and pi and g I've left out. Okay, so 0.7239 pi g is the weight of the alcohol. So the last part of the question then says, if the liquids from parts 1 and parts 2 are mixed, find the relative density of the mixture. Well, to find its density, you're going to say it's its total mass divided by its total volume. So the mass here from part 1, that's the weight, remember, which is mass multiplied by gravity. So the mass from part 1 is 1.026 pi, plus the mass from part 2 is 0.7239 pi, divided by the total volume. Well, the volume from part 1 was 1.026 pi times 10 to the minus 3, plus the volume from part 2 was 0.762 pi times 10 to the minus 3. I've just changed that so that we've got the 10 to the minus 3 here together. So basically I've moved this decimal point 3 places and changed that to a 10 to the minus 3. That's calculator work there. So let's see. 1.026 pi, excuse me, plus 0.7239 pi. Okay, we probably should have cancelled pi's here and made our lives a little bit easier. Divided by 1.026 pi times 10 to the minus 3 plus 0.762 pi times 10 to the minus 3. Okay. Oh, you're kidding. Right. Okay. Well, look, I did this a second ago, just in warm up. 990 kilograms per meter cubed is what we're going to get. So 990 kilograms per meter cubed is the density. They asked for the relative density, which is 0.99. This number divided by 1,000 kilograms per meter cubed, the density of water. Okay. So there's plenty of other exercises in 9A. Not 9.1, 9A, for you to go and try. I'd suggest you try 2 or 3 of them before you move on to the next. Okay, bye-bye.